I'm gonna talk about a problem that I had on a project at work and how I solved it in SwiftUI, a SwiftUI performance thing. So we're building a brand new app at LumaTouch that is entirely built in SwiftUI. We've been working on it for well over a year now, and we have not yet used UIKit anywhere in it. Or it's a Mac and iOS app, or AppKit. And I didn't want to change that. And it has a timeline view at the bottom, and that's sort of maybe the main UI, but it's anyways, all done in SwiftUI with some custom views. And I was noticing that performance in that timeline was getting really sluggish. Just selecting things in it or moving things in it was the animation was choppy, and it just did not feel good. So I did a little work on that and figured out how to solve it. So we're going to basically build that here, and I'll show you how it doesn't work very well, and then I'll show you how I fixed it. We have and assuming Chris says it's okay, I'll share this code after we're done. There's a little bit of LumaTouch code in it, but it's not anything too significant. We have a custom layout that we're using to lay things out. The timeline, everything in the timeline has a time range, a start time and a duration, because these are like video clips and audio clips and things like that. And so to lay those out with the right width proportional to its duration and the right position, we made this custom timeline track layout. It defines a key that you can set on things where you just set a track range, which is a time range, a start and a duration, or start and end time. And then it basically lays those out. So it figures out what the right rectangle should be for a given time range in the overall time range of the whole timeline, which is just like the entire project, and places them there. I'm not going to go through this too much, but I just want to show that we're using this custom layout. It's fairly straightforward. So what we're going to do is we're going to start with a horizontal scroll view, because the whole thing scrolls, and then inside that horizontal scroll view, we'll create a timeline track layout, and we give it a time range. I'm just going to, well, I can actually just do this because I had it here. I'm going to start with a duration of, we don't need it to be quite this long, let's just start with a duration of like 60 seconds for our overall duration. So we'll give this a time range of from 0 to 60 seconds. And then it also takes a zoom factor in pixels per second, so I'll give it that. And then we need to actually put something in here. So for this little demo app, I made a simple data model that is a clip. And a clip is identifiable, so we can use for each on it, but it just has a name and then a time range where it exists in the timeline. But you could think of this like a video clip in an editing timeline. So we'll create a state variable to hold our clips. And I added a static method just to create a random number of clips, sort of roughly distributed along a duration. So we'll just say we want sort of 10 clips across our timeline. And then we can go through those. And I have a clip view that just takes a clip. And so that should be all we need. Of course, I probably forgot something, but and let's go ahead and preview this.
I'm going to show the clip view since it will have the timeline layout key.
Oh yeah, I actually forgot the timeline.
Or is
Thanks
that
for reminding me, because I actually
I was wondering.
Yeah, so and then we give it so that the timeline track layout knows where to put it. We give it a time range, which is just the clip's time range. And there you go. They have labels, but they're kind of cut off. We could zoom in if we wanted to. If we wanted to see those better. For some reason, this preview takes forever. I don't know why it's taking forever right now. It's been doing that. Alright, so you can see a little bit. I'm just grabbing some random words out of the system dictionary. That's not why it's slow, I promise. Yeah, so this works okay, and then we want to add, I want to add a feature where you can, because this mimics a feature in the real app, if the timeline is active, if it's focused, these expand to be bigger so you can interact with them better. So I'll have another variable called isExpanded, and we'll start with this false, but I'll just put a toggle in the toolbar. Toggle. Called expanded. I don't know why that just showed up. And is on expanded. And then clip view actually has another parameter you can give to it. So now if we click on this expanded button, it's still reloading the preview. They get bigger. Let's give that an animation. Oops. Animation. Or we can do easy in out, which I think is the default anyway. And so that when it is expanded changes, they actually animate. And it looks fine. Okay, so that looks fine. What happens if we change so it's great for small timelines, and this is kind of what we saw in our real app. When you're just working on a small timeline, it works fine, but if you've got lots and lots and lots of clips in a really long timeline, that's when things get slow, predictably. So if we make this 10,000 seconds long, like a couple hours, which is long, but it's not outside the realm of possibility if you've got a movie or something. I'm going to zoom out just a little bit again, and then instead of 10 clips, we do, say, 1,000 clips, or I think I did even more than that. Let's do 5,000 clips just for fun. The timeline crashed. I don't know why. Try it again. Usually, if things crash, you just try it again and it works. I probably missed something. Yeah, well, whatever. I'm missing something here. That's not the problem, I don't think, but we'll go back to my actual code. Oh yeah, I did actually add a number of clips thing so that you can say, and I guess I went all the way up to 100,000 seconds.
Yeah, I wonder if like the 5,000 to 10,000 was like breaking some invariant, like not enough space to put in all the clips.
Yeah, it's possible. Although I was trying to distribute those, but okay. So scrolling, it's probably hard to see. You can't feel it like I can, but it's stuttering just a little bit. It definitely does not feel smooth. And if I click on this button, you'll see it's pretty choppy now. You get 3 or 4 frames total in that animation. So that's not good. And it's not that hard to figure out why this might be happening, because we're asking Swift to use a custom layout to lay out across a huge number of pixels with lots and lots of views. And it's horizontal. If this were vertical, we'd say, well, let's just use a list, and we kind of know that under the hood that's probably NS table view or UI table view, and we know those are really good about efficiently recycling views, so the performance is good even with huge numbers of items. Unfortunately, there's no way to just magically say, hey, I want to do that in this case. But the other thing would be, well, what if we could use lazy H stack, which is sort of a solution to this in SwiftUI normally. We can't use a regular H stack because we need this custom layout to lay them out, and H stack won't do that. I started to sort of go down that route. I thought, well, maybe there's a way to just make the existing layout lazy. Unfortunately, there's not. I asked Claude to solve this problem, and it went crazy. It was kind of fun to watch. But it wrote a lot of code that seemed kind of plausible, and every time I would test it and I'd be like, nope, it's exactly the same as it was. Performance-wise, it's exactly the same as it was before. To its credit, it kept it working. Like, it never broke it, which I thought was kind of cool. but it just never actually fixed it. And like AI does, every time you say that didn't work, it goes, oh, you're right, I found the actual problem. You know? So I went through about 5 iterations of that, and then I just gave up and realized I was going to have to solve it on my own. And so, so now I want to show you what I did. The problem is we want this whole view, this timeline, to only render and lay out the views that are on screen at any given time. And as a view scrolls off the screen, we want it to get recycled and reused for one of the new ones coming on screen, like UI Table View does, basically. And we do this in our timeline in LumaFusion, which is built in UIKit. But how do you do that in SwiftUI? So that's the thing I'm trying to solve. So to start out, I made this view called Timeline Scroll View. And if you look at the body, it's actually, the actual view that it displays is super simple. So it takes a closure that provides some content, which is just a view, and it creates a scroll view to wrap that content. So with that, we can just directly replace our scroll view here. Instead of saying scroll view, I can just say timeline, scroll view. It's always horizontal. And it does have a pixels per second, so I'll pass that in. And we'll see why it needs that in a second. So what does it do? Well, it's really just doing one thing. As it scrolls, it's keeping track of the portion of the timeline that's visible. And for our use case, it's sort of most useful for us to have that in terms of time, because the timeline is showing things in a range of time. And so every time the scroll geometry changes, I compute a visible range for the visible rect. The visible range here is a time range. It's pretty simple. I know the zoom level, pixels per second, and then I just figure out the start time based on the minimum x, and then the duration based on the width, and that gives me the time range of the portion of the content that's visible. And then I pass that down to all of the views inside the scroll view via the pixels per second environment variable that I defined. I also give them the visible range in case they want to know that for some reason. So on its own, this doesn't actually do anything, but it also shouldn't break anything, because it will just really behave like a normal scroll view that's injecting this additional information into the environment, but we don't have to use it if we don't want to. And so if I run this again, we should see exactly what we saw before. And sure enough, still works, but it's still really choppy. So now what we need is some view that knows how to take the clip views and only lay out and render the ones that are actually in the current visible range. And so that's handled by this thing called a track view. It defines a protocol called time range bearing. It just is saying the items that you give me need to have a time range, because I need to know whether they're in the current visible time range or not. And then it takes a closure that provides a view for each item. As you can see, it's not actually a ton of code, and its body is really just a for each. So where's the magic here? How does it actually know what's visible? Well, we have this visible item records computed property. It gets the visible range from the environment, from the scroll view that wherever that parent scroll view is, and it just figures out all of the items that intersect that are part of that visible range. There's a trick here that I'll come back to, but that's the fundamental idea. Every time its body is rendered, every time the body is computed, it just looks for the visible items based on the current visible range, and then those are the only ones that actually get rendered in its for each. If you just do that naively, you'll get exactly the same behavior that we've already seen, because it doesn't have any way to recycle views. So the trick to getting it to recycle views is that the IDs that you're passing to the for each, because you remember for each takes an array of things that are identifiable, and it uses those IDs to tell if it needs to recompute various things and create and destroy views and whatever. So if you want it to keep a view and just update it as opposed to destroying it and creating another one, you need to make sure that records in this list have the same ID. So that the whole trick to this, the tricky part, is that item records, which are actually the thing we're passing to that for each, it's just a little struct that wraps the item and then has another ID. It's an int that is calculated based on the index of the item modulo the count of items in the visible in the count of items in the visible range. So what this does is a little bit, I think, kind of clever. It does not try to keep the IDs exactly stable, and if you watch them over time, you don't get what you would get with like a UI table view, where it's really sort of predictable recycling of views. What happens is you always get the number of records that you need for the visible items on screen at any given time, and most, but not necessarily all, of the IDs that it computes will be identical to ones that were in the last pass, where the last time that changed, so that the SwiftUI system won't recompute those, won't tear them down and recreate them. Having this be in a little view that just takes a closure means that we can use it really easily. It basically just replaces our for each. So instead of for each over our clips, we use a track view over our clips. And then it passes the item into its closure. So that actually looks very much like a for each. And I could have called this something like lazy for each or something, I don't know, but I didn't. Now if we run it, yeah, I don't believe you that that's already, maybe it is. So you probably can't tell, but this is scrolling perfectly smoothly. And if I click expand it, that's back to being just nice and smooth. So yeah, that's that. I feel fairly proud of this because it's not actually a ton of code. It's timeline scroll view is 65 lines and track view is another 50. And at the call site, it didn't add any lines of code. We just replaced our scroll view and our for each, and it just magically works. So I think it worked out pretty well. Any questions?
Did you tell Claude the right answer after this?
No, I'm not trying to help that. I'm taking the job.
Would it be possible to use a list view with like a rotation transform?
That's a good question. I did kind of think about that. The issue is, I think the two issues are that we need that custom layout and a list view. If you think about it vertically, that would mean that the list view would be laying things out with heights dependent on their time range and also positions. So there's not an even amount of space between everything either. The other problem with that is I made this look really simple. Our actual timeline has multiple rows and they're not all aligned with each other, and they're not even all actually timeline or I can show you what it looks like. They're not even all they don't even all have those track range layouts. Some of them are completely separate from all that, but they're in a scroll view. So
I've also heard that there can be issues with like hit testing on views that have transforms applied to them. Like hit testing still uses like the original frame instead of the transform frame.
Interesting.
Because like if you think about what's happening in like the CA layer, I believe that the transform is applied to the CA layer, but not the MS view or the UI view. And hit testing is at the view level.
Interesting.
It seems like a flaw.
That could be out of date, but it just seems sus.
what I really wish they had is a new kind of custom layout where you just say, I want this to be lazy, and it's just magic.
That would be great.
Did you look at the geometry reader?
Yeah, so I can't remember the details on this. In a scroll view though, you use that on scroll geometry change.
Yes.
That's how you're supposed to tell.
More efficient.
Because a geometry reader, Yeah, I can't remember. I read about this at the time. This was, I wrote this about a month
I mean,
ago.
geometry reader's only gonna give you the total content space anyway, it's not really gonna tell
Right.
you what your visible range is.
It doesn't tell you what your offset is, it only tells you how big.
Yeah,
I think that-
it
that
just
was-
like greedily takes up all the space and says like, here's info about your dimensions.
Yeah.
Does anybody know why that just turned off?
You tried,
Oh, I know why. It's because I'm only, let's see,
oh, you're sure.
I'm only sharing Xcode. Interesting. Okay, there we go. So this is the real app. We get to watch Chris and Terry talk.
Please don't watch me. Hate watching me.
Why does that look so blown out? That's interesting.
You do HDR on
Yeah, on a TV that doesn't
That's
support.
might be a little interesting, but.
Yeah, so the real timeline has multiple rows all in the scroll view, and it's doing some fancy stuff. And anyway,
Cool. Is this a Mac app?
it's a Mac and iOS app.
So you recently made a Mac app?
Yeah, I'm pretending it's just a Mac app.
Yeah, he only tests on Mac.
I only test on Mac, and I
Our
always.
QA people only test on iPad, so there's a little conflict there.
Just for development.
I mean,
So what it means is you got good coverage.
We do have good coverage.
what it really means is I don't like waiting around for the iOS simulator to do its thing. I just like.
Once we get a device hooked up, then it's
That's still slower than.
not much.
Yeah, anyway, you can see that's a little more complicated, and let's just turn a list on its side, that's all.
It's cool.
Well, I don't know much about Swift, but it seems like what you did is incredible. You've made Swift do what you wanted it to do. You made Swift UI do what you wanted it to do.
Yeah.
It's like, when I go to, on my Mac, when I go into system settings, it seems like is all of system settings using SwiftUI?
I think I heard that, yeah.
And it seems so laggy in some places.
Yeah.
You have to click on something and it seems like it takes several seconds for it to come up.
Well,
So
don't,
it seems like you're doing stuff that Apple hasn't.
Well, in their case, settings might be more system call related issues that they're waiting for data to come back on.
yeah, and also don't get too excited, we're currently trying to track down some even
We've got
worse
some bigger
performance
performance.
issues.
The thing with, SwiftUI is, from what we've found so far, it really makes a lot of things easier until you suddenly hit some point where
It doesn't.
then you can't do what you want to do.
Yeah.
With UIKit, it was always harder to get things relayed out or move things around, and it's so much easier to SwiftUI. We've done so much rearranging here that's a few minutes work. That's wonderful. But with UIKit, there was never that limitation. If you hit it, then you just customize everything you do. Our timeline on LumaFusion, customizes every bit of the layout, including doing sections of the waveform, in 400 pixel chunks so that it's faster. And all of that can probably be done in SwiftUI, but it's a lot harder, to find out how to do it, just because the information's not out there.
Yeah.
And having Andrew do the research to figure that out, and we keep finding those kind of blocks that little by little we find ways around it. And a lot of the problem with SwiftUI is just making sure that you're not having it unnecessarily, rebuild things. And that's one of the harder things to do. And that's where I think our current problem is that in some cases when you're scrolling, the preview suddenly stops rendering. That should be totally separate. That's on a background thread. But there's an interrelation there that we're trying to find right now. And we sort of know what's causing it, but we don't quite know the fix yet. So that'll be another one we have to find a solution for.
Yeah.
Next month's stop.
Yeah, that might be, in my case, I've got a theory on it right now that, our selected clip, which is the one that we move around, I'm gonna move out of the for each loop so that it's separate from, from the rest of it. That might give us, because I did notice it's basically at least reinitializing all the objects for all of the clips, not all the capture clips though, so I still.
Well, so one thing is this optimization right now is only being applied to the caption clips.
Oh.
They're the only things wrapped in the track view.
Oh, interesting, okay.
So we might, but a lot of our clips are one really long view.
Long clip, yeah, so that might be part of the problem.
But maybe we can just make those actually.
Well, that's
smash
one other thing we do is
together.
cut it off, yeah,
Yeah.
that'd be the next advancement to your
But
thing.
yeah,
And that is something we do in LumaFusion is, that's another customization, is if a clip is really long, we just cut it off a little ways off screen, so that it's not such a large, because what that had a problem on UIKit is those are all bitmap backed views. And so you do a really large view, suddenly you have this, huge memory, usage because it's basically doing a bitmap backup of every view that you have. So yeah, you have to do a lot of optimization.
Yeah, I think the biggest problem there is that expanded thing, which is in the actual app. When you toggle that, it's recomputing the body for all of the clips in the timeline, even the ones you can't see. And that was actually the worst thing